Okay, here to calculate this limit, we'll need to multiply the top and bottom here by a term to help us simplify. So we'll multiply the top by root n plus 1 plus root n, and we'll have to multiply the bottom by root n plus 1 plus root n. Multiplying out the top, and we'll get root n plus 1 plus root n. Multiplying out the bottom, that's root n plus 1 by root n plus 1 is n plus 1. The middle pieces will cancel. You'll get a minus root n times root n plus 1 and a plus root n plus 1 times root n. And then the piece at the back will be minus n, root n by root n. So what you're left with on the top is root n plus 1 plus root n, and what you're left with on the bottom is 1. So this looks like, interestingly enough, it diverges. This will be the limit as n goes to infinity of root n plus 1 plus root n, and clearly that diverges to positive infinity. Yeah, that is quite interesting. But I suppose if you analyze the function, that makes sense. Here, if n is really big, the square root of n plus 1 and the square root of n, they shouldn't differ by much. So the difference here should be quite small. And 1 divided by a small number is a large number. So yeah, it does make sense that it diverges. This is an interesting one, actually, quite interesting.